Let's look at another regression model. Oil pipeline. An underwater pipeline is leaking at a constant rate, producing an oil slick on top of the water. The table shows the diameter of the oil slick over several hours. So diameter of oil slick, meters, and then time in hours. In this case, we are actually treating the diameter as x and time as y as we create our scatter plot here. So let's go ahead and start by plotting these points. So we've got 2.8 and then 2. So 2.8 would be somewhere around here, and then 2 would be about right here. All right, then we've got 4.5, 5.1. So 4.5, and then 5.1 would be about here. 5.6 and 7.8, so 5.6, 7.8, somewhere in here. 7.0 and 12.3, so we've got 7.0, 12.3. This is not the most ideal graph right here, somewhere in there. And then we've got 9.0 and 20.3. So 9.0, 20.3. And then 9.8 and 24 would be about here. All right, so we've got a scatter plot. It looks not bad, but for part 2, we're going to now use the technology to find the equation that's going to best fit. And when we use technology, that's definitely going to give us a much better picture of what the scatter plot should look like. It's much more precise. So let's go ahead and go back to our table here. For x, we have 2.8, 4.5, 5.6, 7.0, 9.0, and 9.8. And then for our y values, we have 2.0, 5.1, 7.8, 12.3, 20.3, and 24.0. So here's the picture of our graph. So we can see a little bit better now what this looks like. And to me, it looks like it's kind of increasing a little bit slower, and then it starts to increase very fast. This looks more like an exponential model than it does just a linear line. So let's try and see if we can fit it to an exponential model. We're going to go y1, squiggle, equals, and now for an exponential model, the standard form is a parentheses base b to the power of x1. And there we are approximating our exponential model. And it looks pretty good. This bottom one is a little bit far off, but for the rest of them, it really seems to fit them pretty well. So I think the exponential model here seems to be a great model for the data that we have. So this equation, and I got this from Desmos, it was in the parameters. So it's y equals 1.57 times b was 1.32 to the power of x. Just to show you, in case you missed that in Desmos, it was right down here in the parameters. What is the range of the regression model? So the range of our regression model, back to Desmos, is for this exponential equation, If you see, it goes all the way down to the x-axis. It never crosses it, as a lot of our exponentials don't. And then it continues to increase forever. So this one has a range from 0 to infinity. If the oil slick has a diameter of 8 meters, how long has oil been leaking from the pipeline according to the regression model? Well, if the oil slick has a diameter of 8 meters, that is telling me that 8 should be x. So according to the regression model, we're going to plug in 8 for x into the equation. Y equals 1.57 times 1.32 to the power of 8. Plugging this into my calculator, and I get 14.47. So it has been going for 14.47 hours.